Here we go. One step at a time, don't be living on the line.
In today's lesson, we're going to examine the effect of adding additional units of labor to the production of a particular good in the short run. Today's topic is part of the microeconomics unit on the theory of the firm, in which we examine the behaviors of firms in particular markets in terms of how many workers they wish to hire, how much output they wish to produce, and what kinds of prices they wish to charge for their products. Before we get into details about the cost and price decisions of firms, we're going to talk about a concept called the law of diminishing marginal returns. Now, let's look at our example here. We're going to be looking at the short-run production in a toy truck factory. We have labor, which is represented by our workers on the left. We have capital, which is represented by the tools in the next column over. And what we're going to measure is the change in the output of toy trucks that results from the addition of units of labor to the production of toy trucks in this factory. So we'll also record the total product or the total output of toy trucks and the marginal product, which is the change in total product for each additional unit of labor added. So first let's make an assumption here. We're going to assume that the quantity of capital is fixed in the short run. In other words, our factory cannot vary the number of tools or technology that it employs towards the production of trucks. We can think of it this way. There's one factory, and we can add more and more workers to that factory, but we cannot build additional factories or acquire more equipment to put in our factory. So the only variable resource in this exercise is going to be labor, the number of workers. So let's start with our factory in which there are 3 sets of tools and only 1 worker working in that factory. If 1 worker joins this factory and there are 3 sets of tools, we can assume that that 1 worker will be relatively unproductive and in 1 day will be able to manufacture 1 toy truck. So our total product with 1 worker and 3 tools is 1 toy truck. The marginal product of the first unit of labor, therefore, is 1 toy truck. Marginal product measures the change in total product attributable to each additional worker. Now let's go over to our quantity of labor column and see what happens when we add additional workers. Let's assume that the factory owner hires 1 additional worker. So now there are 2 workers employed in the production of toy trucks. However, since we are in the short run, the amount of capital available remains fixed at only 3. We can assume that with a second worker added to the production process, the productivity or the efficiency with which the 3 sets of tools are used will increase, and the total product of the 3 workers will exceed the total product of 1 worker by 2 additional trucks. Now, due to the fact that the second worker enabled this factory to work more efficiently, 3 trucks are able to be produced, giving us a total product of 3 and a marginal product of 2 trucks. Of course, the marginal product refers to the change in total product attributable to the additional worker. Therefore, as 1 more worker was added, the total product increased by 2 trucks, giving us a marginal product of 2. Now the factory owner decides to hire a 3rd worker. So in the next round, we're going to have 3 workers employed, but again, the amount of capital is fixed since we're in the short run here. With 3 workers, the productivity increases even further. And now, instead of 3 trucks, the 3 workers combined are able to produce 6 trucks total. The capital is being used very efficiently now. Since each worker has his own set of tools to work at, all capital can be used efficiently, giving us a marginal product of 3 trucks. So far, the efficiency of each additional worker has exceeded the efficiency of the previous worker. In the short run, as additional units of labor are added to our factory, the existing capital is used more and more efficiently. Now what happens if we add a 4th worker to this factory? In the next round, let's employ 4 workers towards the production of trucks. Again, however, quantity of capital is fixed since we are in the short run. Now the 4th worker will not have the luxury of having tools to work with. The fourth worker may be able to contribute to the production process, but not by the extent to which the third, second, or first worker added to the production. So what is likely to happen is that with 4 workers, the total product will continue to rise, but it will start to rise at a diminishing rate. So let's say the total product with the fourth worker goes from 6 trucks to 8 trucks. 1, 2, 3, 4, 5, 6, 7, 8 trucks. Total product continues to rise. However, the marginal product now begins to decline. The fourth worker only adds 2 additional trucks to the production process. This is explained by the fact that there are no additional tools for the fourth worker to use. The quantity of capital is fixed and only labor is changing. Now, what if the factory owner decided to hire a 5th worker? In the next round, let's add 1 additional worker for a total quantity of labor of 6, and we'll keep the number of tools available at only 3 pairs, and the total product will once again increase, but we will see it increase at even a slower rate. So let's say that only 9 trucks are made when the 5th worker is hired. The output attributable to the 5th worker is only 1 truck now. The marginal product of labor has declined. The additional number of trucks attributable to each additional worker is now less due to the fact that there are simply no more tools for additional workers to use. While total product continues to increase, the marginal product begins to decrease. Now, what happens if a 6th worker is hired? Clearly, there are no more tools for these workers to use. The 6th worker may be able to contribute to production, but it's more likely that the 6th worker is only inhibiting or getting in the way of the other workers on the factory floor who all have tools to use. This 6th worker will have no tools to use and may actually lead to a decrease in the total product. Let's assume that with 6 workers, total product actually decreases from 9 to 8 trucks. This means that the additional output attributable to the 6th worker is actually negative 1 truck. The 6th worker decreases the total output of trucks due to the fact that at this point he's only getting in the way. There is no way that 6 workers can lead to more production in the short run, given the fact that the quantity of capital available is limited to only 3 sets of tools. So how would this look if we were to take the information in this table and plot it in a numerical table and on a graph? Let's look at the next page here. What we've done is we've added workers. When we had 1 worker, 2 workers, 3 workers, 4 workers, 5, and 6, the marginal product of labor changed each time we added additional workers. At first, 1 worker contributed only 1 truck to the production process. The output attributable to the 2nd worker was 2 trucks, since capital was able to be used more efficiently. With the 3rd worker, we saw marginal product go from 2 to 3, and total product increased from 3 to 6 trucks. Capital is now being used very efficiently. With the 4th worker, however, total output increased to only 8 trucks, meaning that the 4th worker added only 2 additional trucks to the total output of this firm. Upon hiring the 5th worker, total output went up to 9 trucks, meaning the marginal product of the 5th worker was 1 truck, and upon hiring 6 workers, total output declined back to 8 trucks, meaning the marginal product was actually negative. The 6th worker led to a decrease in the total productivity of our truck factory. If we plot these points on our marginal product graph on the right here, we'll have a marginal product curve. Let's do that now. On our x-axis is the quantity of labor from 0 to 6 workers. On our vertical axis is the quantity of output attributable to each additional worker, or the marginal product, from 0 to 6. So at 1 worker, the marginal product was 1. At 2 workers, the marginal product was 2. The 3rd worker's marginal product was 3. However, the 4th worker's marginal product began to decline, and with 5 workers, it was down to 1. And with 6 workers, the marginal product was actually negative 1. If we connect these dots, what we have is a marginal product curve for labor in our toy truck factory in the short run. This is the output attributable to additional workers added to a fixed amount of capital in our toy factory. Let's make some observations about this curve now. One thing we notice is that when workers are first hired, there is a range over which marginal product increases. This we refer to as the range of increasing marginal returns. Between 0 and 3 workers, each additional worker hired actually led to an increase in the productivity of labor, meaning that additional workers were more productive than those hired before them. Now, the reason for increasing marginal returns is efficiency. The 3 tools available in this factory could not be used efficiently by only 1 or 2 workers, and in fact it required 3 workers to achieve the full efficiency of capital use in our factory. However, beyond 3 workers, we began to see the marginal product of labor decline. This range of our marginal product curve is explained by the concept of diminishing marginal returns. Diminishing marginal returns occurs beyond 3 workers in our toy truck factory. The explanation for why diminishing marginal returns occurs is decreasing efficiency. Because the amount of capital available in our factory is fixed, additional workers beyond 3 only begin to get in the way of the more productive workers hired before them. Of course, total output in our factory continued to increase until we hired the 6th worker. However, it increased at a decreasing rate. The 4th and 5th workers contributed to the output of the factory. However, they contributed at a decreasing rate. There was simply not enough capital to go around, and by the time the 6th worker was hired, he actually reduced the productivity of all the other workers in this factory, and the factory's total output fell from 9 toy trucks to only 8 toy trucks. So in this video lesson, we have shown how when a variable resource, in this case labor, is added to a fixed resource in the short run, in this case capital, at first the productivity of the variable resource will increase, as we see here. Marginal product increases until the 3rd worker, but beyond 3 workers in our factory, the marginal product of labor decreased due to the law of diminishing marginal returns. Due to the fact that capital is fixed and labor is variable, workers beyond a certain point are no longer contributing to an increase in the production of this good. If we were to add a 7th, an 8th, or a 9th worker to this factory, the factory would become so crowded and all the workers would therefore become so unproductive that the total product of the factory would begin to decline, perhaps even fall to 0 if the factory became too crowded and there was absolutely no way that anybody could make efficient use of the existing capital. The principle of diminishing returns says that beyond a certain quantity of workers, the output attributable to each additional worker will decrease due to the falling efficiency with which existing capital can be used in the short run. In order for a firm to overcome diminished returns, more capital would have to be added to the production process. Now that would require a long-run acquisition of more capital, and that will be covered in a later video lesson.